Welcome to the Real Python Podcast. This is episode 110. Would you like a way to send structured data between different platforms and languages? What if the data was self-documenting, could automatically generate Python code, and validate itself? This week on the show, Liran Haimovitch talks about protocol buffers and communicating with microservices through remote procedure calls. Protocol buffers, aka Protobuf, are a language-neutral, platform-neutral system for serializing structured data. Liran talks about how they go beyond text-based protocols, like JSON, providing the benefits above, along with faster transmissions and a smaller footprint. Liran shares how his company uses Protobuf to communicate between their tools. We also discuss using gRPC to communicate between microservices and scaling infrastructure in either direction. A little programming note. If you're listening to the show on a platform that doesn't include the show notes, links, chapters, and more, or only show a portion of what I create and compile for you every week, remember you can find all that good stuff at realpython.com/podcast. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Liran, welcome to the show.
Hey, Christopher. It's a pleasure being here.
We kind of gone back and forth a little bit via email, and I got very excited when you mentioned that you wanted to talk about the upcoming talk that upcoming because we're recording this in the future for your PyCon US 2022 about Protobuf and gRPC. We're recording this before you do your talk, which will be next week, and then this will come out a little bit after that. So again, we're doing time traveling, which is always fun.
Yeah, so this talk is going to be taking place in actually 10 days from now, but it's probably going to be 3 weeks in the past or so by the time you hear this episode. I'm hoping it's going to be as fun as the last time I was at PyCon, actually almost 3 years ago now.
Oh, okay.
It was one of my first conference talks. It was super fun. Also one of the busiest. There were about 700 people back then, which I know today in COVID times, thinking of 700 people in the same room is shocking all by itself.
Yeah, it is going to be quite the culture shock. Everyone I work with, I mentioned this on an upcoming episode too, that I'm going to meet all these people in person for the first time that I've been working with for like 2 to 3 years. So that's going to be fun.
Mm-hmm. Yeah, I know for me, conferences have been missing. Actually, I got to be at a few conferences over the past few months, and it's been a blast.
Oh, good.
I know being the CTO of a startup, in meeting our customers, meeting new potential customers, people who are psyched about our technologies, and getting their feedback and learning from them, talking at conferences, all of that is super fun, super cool. I feel like it's a huge part of my job, and that was very missing for me for a long time during COVID times.
Did the reality meet your expectations of getting back into it?
Oh, definitely. Whether it's about meeting the people, whether it's about seeing what new vendors are offering, keeping track of the community, or just reconnecting with people, I actually, back then, before, 3 years ago, I was traveling a lot. I traveled, I don't know, maybe 6, 7, 8 times a year. And I got to make a few friends, especially in the Bay Area and other places where I got to often.
Yeah.
And all of a sudden I was, disconnected from them. No, even leave aside me, one of our solution engineers had family in New Zealand. She hasn't seen them in almost 2 years. Actually, she just went back to them a couple of weeks ago. Yeah. So it's the world we used to think of as so small, gotten crazy big so quickly.
Yeah.
Yeah. But let's talk some technology, I guess.
Yeah. Well, what did you talk about your last time you were at PyCon?
So last time I was in PyCon, I talked about actually debugging Python application, about how are the internals of Python debugging are built. If you might be familiar with the set function, you're probably not. It's probably the single most complicated function within the Python standard library. So I talked about that. I talked about how to use it, what's its performance. Spoiler, it's not very good. And what can you do about it? How can you further improve it? What can you do if you're stuck with it? That kind of a lot of the research I've done about 4 or 5 years ago as I was founding Rookout and trying to build tools that allow you to debug in production in real time.
Cool. Well, I'll definitely include a link to it and people can kind of look into that a little bit further. I wanted to, before we started to get into the talk that you're going to do, you do a podcast right now yourself, right?
Yeah, I have a podcast that I started about 9 months ago. It's called the Production First Mindset. We focus on all the culture, the technology, the tools, the processes, everything that you have to take into account. And you think that your code, when you write a code, it's not just about what's happening on your laptop. It's not about what's happening in the lab. Early on, it might be, but once software becomes commercial, once you're really building apps, then it's all about how do your apps run in production, how do they serve your customers, how do they interact with people, and how do you deliver those applications, how do you monitor those applications, how do you secure them as they are running in the real world. So the podcast is called the Production First Mindset, and that's what we focus on. I interview a different guest every time, kind of try to give a different perspective. It can be about cloud, it can be about machine learning, it can be about security, anything at all, depending on whatever the guest is an expert on.
Yeah, cool. That sounds fun. So this upcoming talk that you have is about Protobuf, and RealPython had an article in 2021, and we talked about it briefly on the show. It was titled Python Microservices with gRPC. It was by Dan Hipschman. David was talking about the article, and so I kind of learned a little bit about Protobuf there, and then a little bit about gRPC. But maybe we should start with the kind of the background. I had thought that was a fairly new concept, and then I went and looked at the documentation. But it looks like Google's been doing stuff with this since like 2001.
Yeah.
So I find that kind of really interesting. So maybe we could start there, or where would you like to start?
Yeah. So I've actually been a serialization connoisseur, so to speak, for the past, I don't know, over a decade, maybe 12, 14 years. And that's because serialization is such a huge part of everything we do in software engineering. Think about it, when you write code, variables are at the core of everything we do, the state of the application. You can't get very far. Maybe you've written print a hello world, but that's as far as you're going to get without variables. Now, once those variables have to cross space and time, whether it's making a network call, whether it's being stored in a database for future use, or anything else at all, you have to find some way to transform those variables into a stream of bytes, an array of, so to speak, and then send it somewhere. And then when it goes around, you have to all of a sudden take that stream of bytes and read it. And there are so many complexities that go into it. On the one, it's the magic that enables modern applications to happen, whether it's about, again, databases, networking, service meshes, anything requires serialization.
Yeah.
But there are tons of difficulties, tons of challenges. And so I've been a fan of that. I've actually written a few serializations formats myself. And when I founded Rookout, we pretty quickly settled on a Protobuf. And I think became some pretty advanced use cases for that, both gRPC and Protobuf. So I'm kind of taking this opportunity to share with the community some of what I've learned, some of the basics on the one hand, as well as some of the more advanced fancy stuff on the other hand, which is definitely useful when you're in a bind and trying to squeeze every bit of performance out of it.
Yeah, definitely. What kind of languages were you working in to create were you working on like libraries and things like that?
So I was actually working on an agent written in C++.
Okay.
And required some pretty fancy serialization stuff. It was a remotely controlled agent. So we wanted to serialize the commands and the inputs and outputs of that agent as it were transferred. And we wanted to make it very agile and sort of abstract away the transport layer from the command layer.
Okay.
So we had a whole bunch of interesting requirements for serialization. And we ended up kind of writing our own. which I think was definitely justified at the time. We got to do some pretty fancy stuff. I also got to use some of the most advanced features in C++ templating nobody ever knows about, which is probably not for our listeners right now, but if you want to do crazy stuff with C++ templates, definitely hook me up and I'll share with you. But yeah, I mean, when you're serializing, especially if you're trying to make it easy, kind of integrating your code, your variables, kind of making it easy to move from the state in memory of the variables to the serialization and move back again. There is a lot of syntactic sugar about how easy it is, and you can very easily end up writing tons of boilerplate code, just converting between the two of them. That's actually one of the things I like the most about Protobuf. It's been around, as you mentioned, for almost 20 years. It's supported in pretty much every language out there. We at Rookout use it for our agents, for Golang, Ruby, Python, .NET, JVM, and Node, or I think, yeah, 6 agents. And so we use it for all of them, use it interchangeably, and it's super easy for all of them. So that's actually a big boon for that. And it's not just about supporting those runtimes, it's about supporting them in an idiomatic and easy to use manner.
Okay. So the idea of it being a standard that can move across these different languages is one of the big benefits that you see of it. It's kind of an interesting thing behind it in the sense that you are mapping out what you're going to serialize in some ways, in that you have to kind of make a bit of a definition of what you're sending and receiving. Is that right?
Yeah, I think that takes us kind of to the topic of static versus dynamic typing.
Okay.
And I know early on in computer sciences, everything was about static typing. And that was because, in a way, computers were dumb, or not so much as dumb as they lacked computing power. And so we had to literally spell everything out for the computer because it didn't have the mental capacity or the compute power to figure it out for themselves. Then, in the 90s came runtimes, languages such as Python and JavaScript that used the fact that computers were all of a sudden more powerful to use dynamic typing to spare us, you, me, the listeners, all the humans here, the effort of declaring what we want to do because the computers no longer needed that. I think the trend we've seen over the past decade or so, and that actually has come to Python as well, is that all of a sudden we're seeing people using types again. I mean, even Python is typing or an optional typing system now. And part of the reason for that is that types today are not used so much to help humans communicate with machines. It's more about having humans communicate with other humans. And in that regard, the data we provide the compiler, the data we provide the interpreter, the typing data, it's not meant to make it easier for the machine. The purpose is to allow the machine provide feedback to our either future self or our colleagues as they are working with the code or format we've created to make better choices and to more easily understand what's going on. Now, one of the benefits of Protobuf, or one of the attributes of Protobuf, if you don't consider it a benefit, is that it is indeed statically typed rather than dynamically typed. And I think that's actually a fairly common attribute for most binary serializer. If you're using a text-based serializer such as JSON, then it's much easier to go down the dynamic route. While if you're working with a binary serializer where performance tends to be of a higher priority, then you would most often see static typing come in as part of the bargain to allow you to get better performance out of it.
And some of that has to do with if you can sort of define what things are going to be, you can kind of set aside the amount of, space or memory or what have you for each of those kinds of materials, and then also potentially, reduce the size of them in some ways when you can be able to convert it into binary. Is that right?
Yeah, it's even more important, I would say, because if you don't specify your schema ahead of time, if you don't provide a type data, then the format is going to have to contain that as metadata.
Yeah, okay.
So essentially, you're creating tons of metadata, and often in dynamic typing, that metadata becomes at the field level. So let's say you have a serialization tree that contains It's a big tree. It contains 1,000,000 attributes, 1,000,000 pieces of information tied together into one dataset. Now, if you're using dynamic typing, chances are you're going to have to add some level of type data to each and every one of those attributes, to each one of those millions. You're probably going to have to add both a name and a type for each of them. And that information can in many cases be even more expensive especially in terms of size, in the term of size of the message, than the actual data you're trying to transfer. Well, if you've created static typing and the machine already knows what goes where, what's the type, what's the value name for each of those fields, then it's much, much cheaper to encode them in a time efficient manner, in a space efficient manner.
That's funny. The information about the information takes up more space, but that is the case.
Definitely. And I think the biggest benefit for using binary serializers is the message size. Now, often you don't care. And if you don't care about the message size, then there's a good chance you would be better off using a textual serializer, such as JSON. You obviously can use XML as a textual serializer, but you probably won't be better off if you use XML for any reason at all. Please don't do that. I'm kind of joking, but yeah, XML is a bit outdated.
I understand. Yeah. I had to work with a bunch of XML I worked at a bank. And so we were trying to communicate with lots of other banking and financial systems. And you would go through reams of paper of XML like definitions and just try to figure out what's going on. It was, yes, potentially it was human readable, but not, not exactly.
Yeah. If you think about what I've mentioned about, they having more metadata than actual information, XML is the perfect example of that. You have so much metadata way beyond what you're actually trying to transform. JSON is much better. It's being human readable. It's pretty much a global standard. You can find great libraries for any runtime. It's truly human readable. It's performant. But still, you're going to probably find that the message sizes for JSON are pretty large, and you can easily get significant size benefits if you use a binary serializer. Obviously, there are other options, compression and other stuff, but that goes into a longer story. But you can definitely get significant performance, both in size and in processing time benefits by using a binary serializer, making things much, much faster. And besides, the way I see it, if you build out a format, one that's destined to live for a long time, hopefully, then you're probably better off going with a static serializer, something that's going to hold metadata about what's the format, about how the data is supposed to be read and written, so that it's going to be easier to maintain that. It's going to be easier to adapt that. It's going to be easier to read very old messages because you know how they're written and why.
Yeah.
So I would definitely recommend that. And kind of going to the end of the conversation for a quick preview, if we talk about gRPC, which is an RPC, a remote procedure call based on Protobuf, then here you are actually building contracts, you're building APIs. And it makes perfect sense that when you're building APIs that are supposed to be consumed by other services, you declare them in a static manner because it's much easier to version them, it's much easier to understand them. And you can think of it more as part of the documentation itself, rather than just telling the machine what to expect.
Yeah, that's kind of the thing that I'm seeing across the Python community over the last couple of years. At least I've been doing the show. You're right. There is this sort of parade of peps about typing and adding it. And in a lot of ways, it can be acting as a form of documentation to kind of see what's going on, but also just like you said, it's this ability to like communicate across these boundaries between languages and machines and so forth. And that's what I kind of find fascinating about this idea that JSON is ubiquitous in some ways for doing API calls and lots of these other types of web communications. But I could see how something like this is going to give some additional benefits. I think that maybe the hard part might be just like wrapping your head around it and having those benefits spelled out to you, because it almost seems like there's like a bit of a little extra step in the setup. But once you've done it, not only does it document itself, but it also adds all these other kind of benefits of being a little more easy to move from language to language.
Yeah, so I think it's all about how long do you expect the piece of code you're writing or the piece of data you're building to be stored, to be used.
Okay.
If you're just building out a script that's going to be used, I know, if you're building an inventory of all your MP3s so that you can go through them and sort them, then probably JSON is going to be great for that. But if you're storing, I don't know, bank accounts,
right,
and you're doing that for a bank and you want to have that data easily accessible a decade from now, then going down the longer route, the more orderly route makes more sense. And it's not always, an either or choice. At Rookout, we use JSON for stuff that we feel would be short-lived.
Okay.
Stuff, elements of the APIs where we want flexibility to reign. We want things to be very quick, very easy to adapt and change. While things where documentation is more important for us, things where performance is more important for us, things where message size is more important for us, we go through the extra hassle of making it using Protobuf, making it static typed, so that we can get the best of both worlds, depending on the context.
Cool. How long have you guys been using it?
So we've been using Protobuf from pretty early on. I think in the very, very first MVP, for the first few weeks, we've used Thrift, and then we kind of gave up on that. We felt Thrift might be the great new thing to replace Protobuf. We were wrong. It wasn't that good, and it pretty much died off since then. And so we went back to the good old Protobuf and we've been pretty happy with it. So we've been using that for almost 5 years now.
What's involved if someone is interested in setting this up? What's it sort of look like, I guess? It's always hard on a podcast to kind of get into the nitty gritty of like explaining these concepts, but I think maybe we could do a little explanation of like, okay, well, what does that look like for someone setting it up?
So let's start by the fact that we understand that Protobufs use what is called auto-generated code. Essentially, auto-generated code is a form, I'm not sure if all of our listeners are familiar with it, but essentially it allows you to get a new piece of code. So usually you have kind of two options. One, you can have your code you've handwritten that you for yourself. The other option is a library code where something has been written for you, but is out of the box. And sometimes, especially as I mentioned earlier on, when it comes to syntactic sugar, library code can be a bit tedious to use, especially when it comes to serialization, or it can be very inefficient. Auto-generated code is kind of in the middle. It's a sort of a template that the library comes with a template, and that template is instantiated based on your needs. So that's what Protobuf is using. The spec files are called .proto. They include all the messages you want to have in your protocol or in your serialization. Messages are pretty straightforward. They look like header files, kind of C or C++ header files. You essentially say message, give it a name, curly braces, and then add a bunch of fields to the message. You can give a field number to each of them, such as, string name is field 1, string date is field 2, and so on and so forth. And then you kind of have your proto file. It's not too complicated. Just look it up, Google it online. You'll easily find it.
Yeah.
Then the next step is to use Protoc, the Protobuf compiler, to generate the auto-generated files. It has tons of runtimes it supports. In our case, just use it to generate your Python files. And once you do that, you're going to have a bunch of new Python files created, essentially one for each message. Then it's just a matter of importing those files, and then you can you have those objects. You can just create the objects. You can assign values to them based on the attribute names you've added to the messages. You can serialize them into a string. You can read them from a string. You can read the attributes from the messages you've deserialized. It's pretty straightforward. I would say you can probably get it up and running. IT aside, it would take you about 10 minutes to create your first hello world with Protobuf.
Yeah.
If things get messy with setting up the Protoc compiler, then it can take a bit longer depending on your operating system and so on. If you're using macOS, it's just a matter of brew install Protobuf.
This week, I want to shine a spotlight on another Real Python video course. It covers a popular topic and common next step for intermediate developers, beginning to test your Python code. It's titled Testing Your Code with PyTest. It's based on a Real Python article by previous guest Dane Hillard. And in the course, my frequent co-host, Christopher Trudeau, shows you what benefits PyTest offers, how to ensure your tests are stateless, how to make repetitious tests more comprehensible, how to run subsets of tests by name or custom groups, how to parameterize your tests, and how to create and maintain reusable testing utilities. Testing your code brings a wide variety of benefits. It increases your confidence that the code behaves as you expect and ensures that changes to your code won't cause regressions. This course is a quick way to get up to speed with PyTest, one of the best tools you can use to boost your testing productivity. Like most of the video courses on RealPython, the course is broken into easily consumable sections, and you get code examples for techniques shown. All courses have a transcript, including closed captions. Check out the video course. You can find the link in the show notes, or you can find it using the search tool on realpython.com. In your talk, you mentioned that there are some performance sort of challenges and trade-offs to Protobuf.
So early on, as I mentioned, we started 5 years ago. We went at it very naive. Now, just to give you some context, what we do is at Rookout, we build debuggers. We build production-grade debuggers, essentially agents. For instance, for Python, we build a PyPy package. You just pip install Rook. And then our package allows engineers to debug their code as it's running, whether it's running in a other machine, in a container, in the cloud, even in Kubernetes or serverless. And we support production environments as well.
Okay.
So essentially, you install our agent, you set a breakpoint in our UI, a non-breaking breakpoint, and we get you a snapshot of the data. So our key priority for Protobuf was we wanted to serialize the entire state of the application into a message so that we can ship it, essentially transmit it from the running application to our UI in the background so that we can reconstruct what's happening in that application instantly without stopping it.
Okay.
Now, this is, I would say, a fairly complex serialization process because you have to serialize pretty much everything, whatever variables are in context, the stack trace itself, whatever is going on within the application, we want to serialize it. So we have to go through all the local variables. We have to identify their types. We have to identify their names. We have to then get their values. And we kind of have to package all of that into a message. And early on, we figured out we want to use Protobuf, and we kind of went about it doing things very naively. We've just created a bunch of fields. And we said, this is the name, this is the size, this is the value, and went with it. Now, as we moved on and had more and more customers using us in production, we've seen there is a trade-off because the more we collect from the state of the application, the deeper we allow it to go, the more time it takes, the more time and memory we need to serialize the state of the application to get you that additional data. And so you're getting kind of that dilemma. Do I want to collect more data about my application, potentially slowing it a bit? Or do I want to do it as fast as possible, even if I collect less data? And so this sends us back to the sketchboards to figure out how can we collect more data faster so that our customers don't have to worry about it so much. And actually along that route, we got our Protobuf implementation to be about 50%, not 50%, 50 times faster.
Okay.
Which was a huge improvement.
Yeah.
And this we've achieved by pretty much breaking down the serialization process and reviewing every little bit of it from scratch. We took a look at how Protobuf is encoding messages. We've taken a look at what processes can be done asynchronously versus what can be done synchronously. We've taken a look at how can we estimate message sizes before they were serialized. We've taken a look at how to, you remember those field numbers I mentioned? Well, apparently, if you select them properly, you can get a huge compression in the message size. But if you select them poorly, then you're going to have trouble because you see, if you use field IDs in the range of 1 to 15, then the field header is going to be 1 byte. But if you're going to use above that, you're going to use 16 or more, then you can get 2 or even 3 bytes header. Now, as I mentioned, think about it. Let's say you're grabbing a snapshot of an application, and overall you're collecting, 50,000 variables. That's all of a sudden extra 50K of data you're grabbing just because the field header is 16 instead of 15. That adds up. So it's not just about having, using just field that is 1 to 15, because at the time we had about 50 fields, and you can't really squeeze 50 fields into 1 to 15. So we had to go about merging them, removing them, and we actually got ourselves down to 12 common fields.
Okay, so you categorize them in a way?
We've categorized them in a way. We figured what can be merged, what can be entirely removed. And by cleaning all that up, we got a huge boon. And that's just one example. Over in the talk, which is by now going to be in the past, I've covered 5 or 6 of examples, as well as practical use cases, how to go about identifying them, how to use them, and share some more of our benchmarks of how we've done things internally.
Wow, yeah, that's a pretty intense application in the sense that it has to be able to scale to debug a huge variety of types of applications. I mean, you could have, whatever the footprint, it could really vary. So that's interesting that you have to really think about that and then have to adapt your solution inside of Protobuf to work with it.
Yeah.
How long is that process?
So I think Python was actually the first SDK we've released somewhere in the middle of 2017. By now, we've added SDKs for Python. We support, by the way, Python, everything from including 2.7. We still support it. I know it's deprecated. We have customers who are using it, and we're there for them.
Yeah.
We support everything 3.3 to 3.10. Again, it's not always fun supporting older versions, but you'll do everything for a customer.
Right.
We have added support for Node.js, JVM, Ruby, Golang, and .NET. But other than that, I just want to touch a bit on actually one of the biggest challenges in Python has been about concurrency. I mean, Python has 4 different ways for doing concurrency. You can do multi-threading, which is not that fun because of the guild.
Yeah.
You can do multiprocessing, which is not that fun because of the memory consumption. You can use greenlets, kind of lightweight user mode cooperative threading, which is not that fun because of the way they hook things. And you can use async IO, which is awesome, but it's not that fun because most of the libraries out there don't support it. Now, that's actually one of the things that I have a gripe with Python. None of those ways work great. And our agent has to work great with all of them. So that's always a challenge, being able to build an SDK that uses actually concurrency internally. And you can install our SDK regardless of what concurrency model you're using. And we still want it to work perfectly, want it to have it performant and not interrupt anything you might be doing in your application. That's actually been a pretty big challenge for us along the way.
I can imagine. And so that has been changing, and there's hopefully some lights at the end of the tunnel as far as maybe making concurrency better in Python.
I hope so.
But you've been focusing on async in some ways. Has that been the one that's been of choice?
So we have actually been trying to limit our usage of threads as much as possible.
Okay.
Because you can never know what you're using. Actually, the way we've ended up approaching this is we've actually created our own custom event loop and pretty much implemented everything we can on top of that. It's definitely not what I would recommend as the best practice in most cases. If you have your own application, choose one of the existing paradigms. I would definitely recommend async IO if the libraries you need support it, because it's the most modern, the easiest to use. It's by far the best. But if you're building a library and you can't make assumptions about the environment you're working on, then you often don't have that luxury, especially as some of the older Python versions we support don't have async IO available.
Right. Yeah, I can imagine that's going to be the trouble spanning across those generations.
Mm-hmm.
I think we got some of the basics of what Protobuf is and sort of static typing of it and how you have to kind of define things up front. Maybe we could shift toward looking at how it's being used in this fashion of remote procedure calls, or And I think it's funny that it's gRPC, but it's like a lowercase g.
Yeah,
I guess that would be the Google's flavor of remote procedure calls.
obviously.
But maybe we could talk about what that is and how Protobuf kind of allows you to do those remote procedure calls.
So I think it's been maybe, I don't know, 6 or 7 years ago that Google is saying that Protobuf is super popular, especially if you look, its niche of a binary serializer. It's probably the most popular binary serializer out there.
Okay.
And they've decided they want to build their own remote procedure call library. It was part of a pretty big initiative on multiple large companies that wanted to move into the so-called cloud native world, building technologies, especially open source libraries that will enable to power applications designed to run in the cloud.
Yeah.
And they figure that they want to take their experience from running, microservices at scale at Google and build a remote procedure call, which is actually derived of a lot of work they've done internally. And so they've opted to go with gRPC, create gRPC, which essentially uses Protobuf over HTTP, HTTP 2.0 to be exact, which is an entire discussion we can have. Lots of good things about that, some not so good things about that. And essentially, gRPC, if you boil it down to the extreme and kind of make, let's say, some incorrect simplifications, it's just running Protobuf over HTTP.
Okay.
Now, you might think to yourself, why do I need that? I can just run Protobuf on top of HTTP. Well, you can, but there are a lot of things that have to happen in between, such as routing of requests based on URLs, such as validating inputs and outputs, such as controlling concurrency, such as adding a plugin mechanism for security, auditing, logging, and so on. And essentially, they've built a framework that allows you to get all of that out of the box. You can start very simply, then you can build on top of that as you need. Now, gRPC uses those same protofiles, and instead of just defining messages, you can also define services, and those services are converted behind the scenes into HTTP endpoints that your servers can listen on and that your clients can reach out to. And then you can just make those remote procedural calls using the same Protobuf-oriented syntax in a very clear and easy to use manner. Now, gRPC is much younger than Protobuf, and while it's popular, it's not as popular. We've actually had experience at Rookout using gRPC in 2 places. One of them was using it in our agents. In the earlier version of Rookouts, our agent communicated with their managers through gRPC. We've actually walked away from that. I can explain why in a bit.
Okay.
And we also use gRPC quite intensively in our own cloud platform for having our microservices communicate with one another. That's actually something we're very, very happy with and are growing with all the time.
So kind of as a generalization of what a remote procedure call is, and kind of comparing it to the typical API, REST API style of the commands that you would use via HTTP, you're basically calling functions across the network, which is a little different. I think things are going to look very different in the design of this API, and I'm not even sure if the term API applies when you're using something like a remote procedure call.
So it's first and foremost a matter of abstraction. A remote procedure call attempts to make things look as a classic function call. Essentially, you're writing a code, you want to call a function, call it print remote, whatever function you want to call, and you want to have the look and feel of just calling a function.
Yeah.
Yeah, behind the scene, it might be using HTTP, it might be using a queue, it might be using tons of things, but remote procedural calls are about abstracting the complexities of the underlying infrastructure and allowing you as a software engineers to just call a function, so to speak. Again, to a great degree, it's about syntactic sugar, it's about simplification. You can just go ahead and make it a function call. Behind the scene, this function call might invoke a REST API, it might have a retry mechanism, it might involve authentication, it might involve login, it might involve tons of stuff. But as for the engineers who are using the service, all they see that they're making a function call. Now,
Nice.
in many cases, REST, or what you do, especially if you're looking at modern web servers, REST are also function calls. When you're putting into a REST API, you're essentially adding an item. You're calling the add item function. But the thing is that when you're using REST, that's not abstracted away. You're literally crafting the HTTP request. You're building out the URL. You're setting the HTTP verb to put, and you're adding the content in the HTTP body, and so on and so forth. When you're using an RPC call, you're just calling, collection.add. This is my object. Godspeed. Let me know if you succeeded. And you don't have to worry about all the underlying thing. And if you look at gRPC uses HTTP 2.0 behind the scenes. So they convert, for instance, each function call gets its own URL. But tomorrow I can create a new library that would convert things differently. And for you, as long as you recompile both the client and the server, that won't matter. As long as I'm taking care of that abstraction for you, you don't have to think about how are things being represented below the fold.
You mentioned that this is popular for microservices, and you kind of mentioned a handful of those. Generally, microservices can be, so many different things, but you mentioned like security, authentication could be one of them. What are other examples of where you would potentially use gRPC for these types of services?
So gRPC, like all RPC calls, have two main use cases. The first use case is about microservices. One service communicating with another microservice. And microservices can either be non-functional, they can be about security, they can be about authentication, they can be about logging, they can be about backup, or they can be functional. You can create each domain can have its own microservice. You can have a microservice. Let's say you are, a car shop. You can have a microservice for cars. You can have different microservices for bikes. You can have a third microservices for rentals. And that's really up to how you build things in your environment. And obviously, all of those have to interact with each other in various ways. And you can use RPC for that. The other option, you can actually build web APIs. You can create APIs that everybody can consume outside your organization. And you can also use gRPC for that. And we're seeing more and more gRPC being used for web-facing APIs. I think the most obvious examples is the Google Cloud Platform, GCP, which offers for many of its API high-performant gRPC options, which are especially useful for APIs where you're running a high workloads under heavy duty, such as subscribing to queues and posting to queues. And the fact that gRPC is more efficient than traditional REST APIs can definitely make an impact there. So yeah, you've started talking about microservices, and I think it's important that when you think about microservices, you think of the logic behind that. Now, microservices are kind of a way of breaking your application apart.
Right.
In the past, you might have written a monolith. I can argue that in the future, you might also write a monolith, but we'll touch that in a bit. But let's say for some reason, you want to split your application into two applications or three applications, because let's say, for instance, your group has three teams and you want each team to have their own code base with as little dependence on other teams as possible. Now, all of a sudden, I've just made your world way more complex because now you have three projects and they have to communicate between one another, and all sorts of method things come into play. Now, RPC, remote procedure calls, are one of the main ways to minimize that extra complexity. Now, to be frank, calling an RPC is still more complex and more troublesome than making a local function call, but it's way, way, way less complex than having to encode whatever request you're trying to make into an HTTP call and then verifying the result. So think of it that as you're breaking down your application into three microservices, the barriers are the RPC calls, which to a certain degree, if your application is well abstracted and you're breaking down across valid lines, across domain lines in a well compartmentalized manner, then those RPC calls are going to be fairly easy to create, and you have essentially separated your code with as little effort as possible without having to create all of the sudden additional work for the engineers themselves that are trying to communicate between those microservices. Now, the main two reasons to create microservices, one is about team agility. We've seen that huge monolithic code bases can be very, very difficult to manage. And second is about computer efficiency. As you're getting in very large scale, as you're optimizing concurrency to a great degree, then being able to customize that is important. Being able to set different scaling strategies for different endpoints, different concurrency strategies for different endpoints, and so on and so forth, those things become valuable. Now, the thing is, when it comes to microservices, and they're super popular a few years ago, is that companies saw that microservices were better than monolith. And they are. If you have 100 engineers and all of them are running on building the same code base with the same application, agility is going to be hard.
Yeah.
If you have a thousand engineers working on a single code base, building a single application, agility is going to be even harder. And so we figured out that if we have 1,000 engineers, one microservice, one monolith application is not that good. It's better to have two, maybe 5, maybe 10. But at some point, the numbers don't have to keep going up. If you have 1,000 engineers, even if you have 1,000 engineers, having 1,000,000 microservices is not going to be better than having 1,000 microservices. And if you have a 10-person team, you may be able to stick with just one monolith for now. And we're also seeing more gray areas. For instance, even though you have one code base and supposedly one application, you can actually use an orchestration platform such as Kubernetes to create multiple deployments of that single application. And then you can use a load balancer to route different requests to different deployments. So that even though you have just one code base, you can logically have multiple microservices. And there is a lot of flexibility here. And we're seeing that this is much more of a delicate balance game, and there are plenty of gray in the middle and various of hybrid options you can choose along the way.
Yeah, it sounds like that's an answer to a variety of things. One being the code base itself and not blocking other people's development of features within a monolith type of structure. It also allows people to kind of have expertise in different areas, which I think is great. It could potentially allow for versioning of these things kind of independently, which I think could be really great. But probably the biggest one is with cloud type architecture, the scaling that you mentioned, I think is probably the biggest one.
Definitely, but it's also important to remember that except for our listeners who are from Google, the rest of you are not from Google. You are not yet running a planet scale web platform. You don't have
Right.
millions of servers. I know that we at Rookout, even though we're serving over 100 customers, and we have got I don't know, maybe 100,000 servers connected to us, and we are allowing many engineers on a daily basis debug their environment. We have about 15 servers in our cloud environment. That's it, 15 servers. So scale is definitely important, and when you reach scale where those things matter, optimize for them.
Right.
But premature optimization is the root of all evil, and premature sharding to too many microservices is exactly that.
Yeah, I can definitely see that. And I almost was thinking sort of bidirectionally in a way that scaling, I think maybe generally is thought of like, upward and growing huger. But I'm thinking of potentially you would have the ability to scale back too in a lot of ways, which I think that, can help. But that's always been an interesting conversation. I haven't had many of those conversations on the show. I'm trying to get more into, data science and some larger applications, but I've heard in a lot of the Python conversations this idea of, that kind of back and forth between monolithic sort of structure and microservices. But I think this might be an interesting bridge for people in the sense that it allows this communication between them. Is that what you've seen? Like that Protobuf has helped you to be able to do that more?
Protobuf has definitely helped us bind our microservices together.
Okay.
Actually, along the way, we've had our own growth and contraction phase. We started with one monolithic application, and we grew up to almost 10 microservices, and then we've scaled way back. We now have one repository which is hybrid in nature, as kind of as I mentioned, but we build about 4 or 5 different microservices out of the same code base. And we have a second separate microservice, which we keep separate for 3 specific reasons. And Protobuf has definitely helped us bridge language gaps and keep Python and Node working comfortably side by side.
Yeah.
As well as keeping stable APIs over time.
Yeah, that's one of the things that seems interesting. And I had another conversation with somebody else talking about another database tool and sort of an ORM that was able to work across lots of different databases and so forth. The idea of being able to talk to different languages is becoming, I don't know, in this world, that's becoming like a pretty common thing that you would potentially need. I would guess that would be even more in the case of microservices where certain things may work better in different languages.
Mm-hmm.
I'm not positive because I haven't worked that much in that field. So
that's definitely the case. I think there are a few reasons behind that. If you look at some of the older computer languages out there, such as C++ or even Java to a certain degree, they were super complex. In fact, even if you look at the full spec of Python and meta classes and all of that, there's super fancy, super complex stuff you can do. And it can take years to truly master a computer language.
right.
On the other hand, sometimes it doesn't matter if you're the top master of that application, because let's say you want to do data science, which you've just mentioned. You can be the best Java expert in the world. Chances are you're going to have a much better, easier time doing data science as a beginner Python developer than as an expert Java developer.
Yeah.
Because different programming languages do things differently. And whether it's about the language itself and whether it's about the runtime and its characteristics or even about the ecosystem, you get different benefits out of different runtimes. And so today we're seeing more and more engineers focused on being polyglot, focused on getting by with the right tool for the job and doing whatever is needed rather than just trying to master one language forever and ever and spending a decade at it and being the best at it. And as you shift to that mindset, as you want to use each language for whatever it's best at, then you're often going to find yourself running in an environment where multiple languages are used. Now, obviously, every language you add adds its own cost, its own learning curve, its own problem. Again, it's a balancing game, because if you select a great set of languages that complement each other, that both interact well with one another, but also each has very different strengths from the others, then often you can get more by having 2 or 3 languages within a team or within a small group, rather than trying to use one tool for everything. Because, if when you have a hammer, the world is a nail kind of mentality, doesn't work that well when it comes to computers.
Yeah, definitely. Yeah, I mean, even the concept of microservices and Kubernetes, like people make jokes about it, like where learning the technology, it might make sense to build a Kubernetes cluster for your blog engine or whatever, but in most cases, that's not something you're going to get into.
Kubernetes is the answer to everything in the same way that assembly is the answer for everything. You can obviously get the job done with it, but would it be the most efficient and easiest way to do it? That's not always the case.
Yeah. You mentioned it a couple times. Tell me a little bit more about Rookout and what you're doing there.
So, as I touched briefly earlier, Rookout is about enabling developers to see into their code as it's running. You can install our agent for Python, or if you prefer, for Node, Golang, Ruby, .NET, or the JVM. And then you can instantly see how your code is executing in any environment, from your laptop through containers, serverless, and all the way to production. And it's very easy to get started. We actually have a free edition online. What I do, I'm the CTO of the company. Early on in the in the company. I actually wrote some of the code. I hired our first engineers. I did a lot of the security and product work early on. Today, I'm focusing more on the community, on the strategy of the company, about interacting with our customers and the communities around them. And that's why kind of, hopping into cool podcasts such as yours and hoping going to meet you at PyCon when I get there next week.
Yeah. I have a few of these regular weekly questions I like to ask everybody. The first one is, what are you excited about in the world of Python? It could be an event, a book, package, editor, what have you.
So I think I'm most excited about PyCon and being there again next week. It's going to be the biggest conference I've been to in a while. I'm hoping I'm going to have a great talk. I know I've been preparing a lot for it. And I'm sure you can, by now it should be available online as it was recorded, so you can check it out. I'm also always having fun, using PyCharm, the JetBrains IDE for Python. It's always making development so much greater and easier. And especially getting all our unit tests running and seeing them pass and debugging them as needed. That's always fun.
Yeah, cool. What's something that you want to learn next? And again, it doesn't have to be Python or even programming specific.
So I would actually love to learn Rust. In the past, I did a lot of work around C, C++ for many years. I've been off that, I think, for 6 years, doing mostly high-level work around Python, JavaScript, and so on. I feel like going back to the roots. I know Rust has been gaining popularity. It's supposed to have some pretty cool features and interesting learning curve. And I would love to dig into that and maybe add Rookout support for that as well.
I would have to say that's probably the most popular answer I've had. Is people do seem to want to learn Rust. It seems to be very, Python adjacent for a lot of the developers I talk to.
Yeah, I've heard some cool things about how it manages memory and how some of the abstractions look as you're writing code.
Yeah, great. So we kind of end each episode with how people can connect with the things that you do online.
So on Twitter, I'm Liran_last. You can probably Google me to find my Twitter, my LinkedIn. If you Google me, you'll definitely find the talk I'll be giving at PyCon next week.
Yeah.
Also, would love to see you guys and girls sign up to Rookout and give us some feedback on what do you think.
Cool. Yeah, I will definitely include links to your Twitter and the talk if it's up by the time this comes out, which I hope it will be.
Mm-hmm.
And I really want to thank you for coming on the show. It's been really awesome to talk to you.
It's been a pleasure.
I want to thank Liran Haimovitch for coming on the show this week. And I want to thank you for listening to the Real Python podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.